Hello and welcome to a new episode of Rail Insights by voestalpine Railway Systems. My name is Gernot Frischenschlager and today we'll be discovering a new color in rail spectrum, the green one. In an era of climate change challenges and increasing need for sustainable transport, rails can definitely provide a major contribution to a decarbonized future. But can they really bear the weight of that responsibility? We take a closer look on how material science and design choices try to answer this question.
In all transport modes, we have CO2 emissions and therefore we need to reduce it. Of course, the railway system has the least emissions, but nevertheless, there are emissions. In Austria, 50% of the emissions are coming from train operation and 50% are coming from infrastructure, so there is a potential for further reduction. One driver is the primary emission of producing the materials. And in the railway system, there are two materials causing high CO2 footprint. That's cement and therefore the concrete, and it's steel. The second lever is to increase entire quality of track, targeting higher service life.
As we all know, renewal always means a lot of effort and costs. Therefore, it's all about reducing wear and tear factors such as corrugation and head checks. So what we need is continuous maintenance and, above all, making our rails as resistant as possible from the very beginning.
Service life is key, not only for the environmental performance of a product, but also when we talk about the economic performance of a product.
A proven method of achieving that is adapting high-quality base material to a specific area in combination with a special heat treatment procedure.
If we think about it, when we can double the service life, we only need half the resources and also half the environmental impacts associated to the production processes of these resources and components.
However, there is not one single best solution. Different tracks have different needs, and in the end, it's the industry's responsibility to adapt to versatile requirements. So, what do operators actually need? And what is their perspective on the future role of sustainable rails?
Alle Schienenverkehrsunternehmen werden in der Zukunft wesentlich mehr leisten müssen. Ich denke, man muss in Zukunft wesentlich mehr systemhaft denken. In der Vergangenheit hat jetzt, egal ob es jetzt um ein Fahrzeug ist oder die Schiene geht, hat also der Hersteller ein Produkt geliefert, der Betreiber hat es eingebaut, betrieben, benutzt, später auch wieder abgebaut, wenn es also die Lebensdauer, das Ende der Lebensdauer erreicht hat. Und das muss einfach systemhafter werden im gesamthaften Denken.
In the interactional cooperation between operators and the industry, it is important to share data, share know-how about the performance of the product and the service life, because then we can jointly work on initiatives to prolong the service life, which is an important part in sustainability.
Der Betreiber braucht quasi auch technologische Erfahrungen, wie das Ding richtig zu betreiben ist, zu pflegen ist. Umgekehrt aber der Hersteller sollte auch wissen, wie ist der Lebenszyklus, die Beanspruchungen, damit in Summe das System umweltfreundlicher wird, langlebiger wird und verlässlicher wird. Daher befassen wir uns mit Kreislaufwirtschaft, Stoffkreisläufe, natürlich Alternativprodukte, eventuell zu herkömmlichen Produkten, um einfach den CO2-Footprint auch der Erstellung der Infrastruktur möglichst klein zu halten.
In the light of a worldwide increasing demand of scrap and the implementation of national circular economy strategies in many countries, scrap will be a very valuable and maybe also rare resource in the future. Therefore, it is essential to use scrap locally, regionally, and also to use it within the sector.
Summing things up, we see that creating a sustainable rail is not about a singular measure in production, but about getting a holistic, long-term view over the whole product life cycle. This is where life cycle assessment comes in, or in other words, systematical determination and collection of environmental impact data over all stages of the life cycle. To make this data accessible, we use so-called EPDs, short for Environmental Product Declarations, representing one of the results of our research efforts together with our partners at Technical University Graz.
The data you need for life cycle assessment of railway infrastructure is on the one hand technical data, so the technical behavior of railway track. Also, we need data on the environmental performance of the components. Companies are publishing, and voestalpine is really a front runner in that regard, transparent data on the environmental impact of their products, which is also externally reviewed. So this is for us then reliable, transparent and specific data we can then use for our evaluation and hotspot analysis. This is one main takeaway, so that we do not stop with our environmental calculations at the part of the production, but also take the whole life cycle into account, because only then we can make the right choice from a sustainable point of view.
Sounds pretty simple, right? Rail longevity seems to be the solution. But as we all know, there is a second key factor for operators called cost efficiency. And that is exactly where life cycle costing comes in.
My research is focusing on combining life cycle assessment, environmental impacts, also with life cycle costs. This also includes research on environmental pricing schemes, so that environmental impacts like CO2 equivalents, for example, are not only a soft factor, but can also be implemented into cost-based schemes within the procurement process, for example.
And this can make a remarkable difference. Let's take a look at the example of the European railway corridor from Genoa in Italy to Rotterdam. E.g., for narrow curves, the expected rail service life can be stretched from 2.3 to more than 14 years if we compare 400 UHC HSH steel to standard rail steel R260. This adds up to savings in CO2 equivalents of more than 40%. Definitely a big step, but in terms of cutting emissions, there is even more potential if we look at future steel production.
Rails as a product per se are sustainable. They are made of steel, and steel can quasi be recycled endlessly. The point today is that in particular rails are mostly produced in a production route that is based on the use of primary materials, notably iron ore, coking coal, and only a very limited part of scrap. Our target is the elimination of the coking coal and these CO2 emissions by changing the production route. voestalpine has introduced an ambitious and engaged transformation plan to reduce the CO2 emissions in the steel production. The plan is to reduce the CO2 emissions step by step. The first step will be a reduction of 30%. This will be achieved by the implementation of an electric arc furnace, which is operated on the basis of renewable energy. The second step in this transformation will be a climate neutral steel production, and the target is to achieve this climate neutrality in steel production by 2050. My vision for the future of rails is that we use the right product for the right application and therefore achieve the maximum service life and the maximum contribution to sustainable transport, which railway definitely is. And that then when the end of life stage is reached, the rails are coming back and become new rails again.
What started out as a vision is now developing into a clear path into a green future. We at voestalpine Railway Systems chose to take the first step towards a sustainable rail life cycle. Thanks for your attention. See you again for the next episode of Rail Insights.
voestalpine, one step ahead.